for the first time we can see that Alzheimer's disease is no longer intractable. We have a very clear path to reducing the severity and slowing disease progression in Alzheimer's disease. So that's really encouraging for all of the other therapies that are sort of up and coming, is that we actually can do something to better this disease. So yes, this year has shown this big breakthrough in being able to reduce the amounts of beta amyloid protein in the brain, but we have this other protein pathology in Alzheimer's disease called tau.
Dominant risk factor for any kind of this disease. So we want to understand how the different population of neurons are aging and whether we can target that to kind of like slow down the progression of the disease. So that's kind of like the hope of this kind of project.
You have sort of the earliest pathology showing is beta amyloid. So you can have amyloid accumulation for quite a number of years before you experience any significant cognitive decline. But once the tau protein starts aggregating and accumulating within the brain, that's where we really see this strong correlation with cognitive function. So you really start to go downhill once tau starts to increase.
Fluctuations in color are actually the neuron firing.
So if we're actually able to reduce the amount of the gene, the MAPT gene that then encodes the tau protein, we actually see a really good safety profile in patients and reduction by about 50% of the amount of tau released into the cerebrospinal fluid, which is a really nice endpoint and points us in the right direction. So ultimately, I think that combining treatments against beta amyloid and against tau are going to be the way that we're able to actually stop dementia.
Many people who have these proteins never go on to develop dementia. So the predictive value of these proteins alone is not very good. So if you think of someone who comes maybe 15, 20 years before symptom onset, for health screens, perfectly normal, do a plasma test of these proteins and find the proteins are elevated. That information doesn't help you because you don't know if this person actually goes on to develop dementia or not. Also, in Alzheimer's disease, we know that specific brain areas are specifically targeted. So in particular, the hippocampus, which is a region that's important for memory. And we know that the hippocampus has very specific signals and electrophysiological signatures compared to other brain areas. The important question is how early in the disease process do they become abnormal? Because we think this could be something that becomes abnormal before cells are lost. but after the proteins accumulate in the brain. So it sits in between these changes.